how it still remembers this count the next time. This behavior is being possible due to the closure, one of the most confusing and typical topic of JavaScript. But in this video, we will surely nail it. Stay with me till the very end of this video and you will master closures very easily. And also we will be talking about how it is complementing the lexical scoping. Starting with the lexical scoping, you can think of it as a kind of a rule. So it is basically a rules which says that the scope of a variable is determined by where the variable is defined in the code, not where the function is called. So doesn't matter where you are calling that function, will you be able to use a variable will actually be based on where you are defining it. And in simple language, we can say that a function can be accessed variables that are defined in the scope in which it is created. It is known as lexical scope. So to get this a bit better, we also have a practical example, but just keep in mind if in an interview you are asked what is lexical scoping, so just keep in mind your some certain words, like you can say that it's a rule that means that a function can access variables that are defined in the scope in which it is created. Just memorize a bit of the definition so that you will be able to give some answer. Closure is just a function. Like lexical scoping is a rule that talks about where a function can be, where variables can be accessed. But a closure is a function that remembers its lexical scope. So closure is a function, it is a function, and that function will remember the lexical scope. Lexical scope was what? The other variables. So even when it is executed outside of that scope. So a closure is a function that can remember its lexical scope even when it is executed outside of that scope. And it also says that inside another function, suppose a function inside another functions that remembers the environment in which it was created, and that environment even after the outer function has finished running. So I know these things are quite complicated, so we will have a practical example to get it better, but like we can see how both of these things work together. So when an inner function is defined inside an outer function, suppose you have a function and inside it you have another inner function. The inner function has access to all the variables and functions in that outer function scope. This thing should have been clear that if you have a parent function and inside that parent function you have a variable and also a function with the say name child function, so that child function will also be able to access that variable because both of them are siblings and both of them are inside that parent function. So this is mainly the scoping, and this is because of the lexical scoping. We are able to get that variable, the child function will able to get that variable because of the concept of the lexical scoping or because of the rule of lexical scoping. And the other thing is that suppose you have the variable's value is 10 and inside that function you are incrementing it with 10 every time. So if you run that function once, so its value will be changed to 20. But again when you will be executing the inner function, it will still remember the previous value at the last function call. So if it was 20 earlier, then it will go to 30 this time. So this behavior of the inner function to remember the previous stage, even though the variable was not actually defined in itself, it was defined in its parent, even though still it remembers that value. This is the concept of the closure, that it is still able to remember that, because even when the function have executed, but still the inner function can still access or remember that value. Now to get it better, let's go to the practical example. So here we have this function of create counter. Inside this we have this variable which we used let, in which we use let. So let count is 0. It is 0. This is a private variable because it cannot be accessed directly. So this is a private variable, and this variable can only be used by the other function inside this create counter. It cannot be used by any other function outside. So this can only be used by the inner functions that are there. These inner functions are able to use that, are able to access this count. Why? Because of the lexical scoping rule. They are able to use it. And now like we have used this const counter. We are here doing this create closure. We are running it, and now when we are running it, first we run it for increment, then again we run it for increment, and then for decrement. So let's remove the first one and let's just do it for the first increment only. So this is very simple. Create counter we are running, and here a closure is being created. So closure is being created. Why? Because we are returning this function. These are the inner functions that we are returning, and they will be able to access its value because of the lexical scoping. They are remembering their value because of the closure. Closure is basically a function. So closure is a function, and that we already like learned it now, that closure is a function and it remembers its lexical scope. The behavior of this function remembering its lexical scope is basically a closure. So let's again go back, and if I run, so you can see we have got the 1. Why? Because it was 0, and then we did this counter dot increment, and when it got to counter dot increment, we are returning it, and when we are returning it, we then because we did increment, so this function ran, it took the value of count, it just modifies that count variable, and it then changed to 1. Okay, so now if I run this again, this counter, what do you think the next time what its value be? Its value is already like it's 1 at this moment. When I run it again, so first it was 1, then it got changed to 2, even though that counter was run before. So still when we are running it again here, when we are doing this counter dot increment, we are not running this again, this complete function, this create counter, this whole function, we are not running it again, but instead we just took this counter and we did this increment part again. But still, how it still remembers this count the next time? This behavior is being possible due to the closure thing. It still remembers that thing. That is why it is like giving us the output of 2. And if I again do it, it will just give me 3. It still remembers it. And we can also do this with the decrement, and it got to 3, and now we will decrement it, so it will again become 2. And we can also run another function, that was get count. So here we have this get count. It will just give us the value of count, what it is. So it got again to, okay, we need to, because here we are returning it, so to check its value we will need to do console.log. And now if we run it, yes, we are getting this 2. So we are not running this create counter again and again. Instead, this just ran once, and then we are again running the inner functions. But still these inner functions, they are able to access the variable of this count every time, and they are able to remember that value. They are still able to remember that value. This is only being possible because of the closure thing. And the lexical scoping is a rules that says that this inner function will be able to access the other variables that are defined inside the parent function. So this count, this increment function is able to access because of the lexical scoping. And closure is basically that the function, the inner function, remembers the value of that variable, even though the parent function has already been executed, still it remembers the value. So that is the closure. So this is the way both of these things work simultaneously with each other. You can actually go and solve more problems related to this, and many times different questions are asked in the interview process to like confuse you up. There is a little summary also, that the inner functions increment, decrement, get, count form a closure over the count variable. They remember the environment in which they were created, which is inside create counter. The inner functions are still can access the and modify the count variable, even though create counter has finished executing. This is possible because of lexical scoping. When we call the methods, they still have access to count due to closures. They are able to access the values because of lexical scoping, and they remember the value. They still have the access due to the closure property, and which keeps the count variable private, and it is encapsulated within the return object. So this count is always private. We are able to access it through the different functions. So this is all about the lexical scoping and closure. These are quite of a theory topic, but like their practical implementations works when you are working on like different functions returning different things and in a more complex approach. But you should know their basic, their definition, their concept clearly, because like in tricky situation they comes, and if you know their proper, like what is their concept about, how you can use it, what kinds of problem do they create when you are coding, so it will actually become very helpful for you to track these all these situations. So that's it for this video. If you haven't watched the other videos of this playlist, please do watch them, and that's it for now, and thank you for watching.